Hello everyone. In this video, I am going to discuss introduction to the signals and systems subject. This is one of the basic and important subjects for all electrical branch, electronics branch and computer science branch. Because this subject is completely deals with basic available signals and what are the available electrical signals, what are the graphical representation and functional representations of the signals, and also discussed with the systems, types of systems, right? So how to design the systems and what are the characteristics of the systems, and whenever one input signal is connected to the one system, then how to determine the response of the system and how to determine the frequency spectrum of the input, output and system function. It is also one of the basic subject for the all remaining subjects to understand the next level subjects. Compulsory we have to understand this signals and system subject, because in every subject we have to deal with the electrical signals, AC signals and DC signals. Every circuit or every instrument, every device requires both signals, AC signals and DC signals. And to understand the AC signals, types of AC signals and how to draw the graphical representations, and DC signals and what are the characteristics of this signal, to understand that compulsory we have to understand this signals and systems. So this subject main aim is to understand the basic concepts of the signals, types of the systems and applications of the systems, and how to determine the responses of the system. Now, first of all, here I want to write the basic definition of the signal. Signal conveys the information. Conveys the information. The name explains which conveys the information. That conveying information purpose we can use different types of representations. Now I want to take one example, traffic signal. The traffic signal consists three different colors. Each color conveys the one information. A red signal, that red color light explains the stop. Green color light explains the go, and yellow color light explains the slow, go slow. Totally each three colors are there. Each color explains each color conveys the one information. That information is how to go on the road. So those are also called as signals. That's why we can call it as a traffic signals, which conveys some information: stop, go and go slow. Similarly, in real time, we can use the different signs to convey the information, like hello, hi, right? So these type of signals are used to convey some information. So finally, the signal conveys the information. And mathematically, we can write here one small simple definition. A function is varies with respect to the time. The function varies with respect to time or space. So this definition is generally used in mathematical analysis. So now I am taking the function. Function I am assuming on y-axis. Always here we have to use two axes, y-axis and x-axis. So y-axis, this is I am assuming as a function. And one more axis I am taking x-axis. X-axis I am taking as a time axis. Now observe this graphical representation. This point explains the origin point. Towards the right side, this side it is completely comes under positive time axis. So generally we have to take the positive values 0 to up to infinity. And similarly towards the left side, this side it consists a negative time axis. So negative values -1, -2, -3 up to minus infinity. So with respect to time axis, a function is changing. Now I am drawing one simple signal. Standard signal generally uses signal one sinusoidal signal. Sinusoidal signal is changing with respect to time like this, exponentially increasing and decreasing with respect to time. This is also called as one signal. So for easy understanding purpose, I wrote a sinusoidal signal. So from this we can write the simple definition. A function varies with respect to the time or space. This is the mathematical definition of a signal, right? Example, electrical signals. Electrical signals are like a voltage, current, those are comes under electrical signals. All those are comes under the signals only. And the power also we can take, right? And sometimes we can use traffic signals. These are the general examples of the signals here. And now onwards we have to take the mathematical representation. The mathematical representation purpose, we have to take the two axes. One axis should be always x-axis and another axis should be y-axis. So y-axis always explains the function name of the function, and this x-axis explains the time axis. So the function is changing with respect to time. That complete representation always write like this, f of t. Here f is the name of the function and this function is changing with respect to time. So within the brackets you have to indicate x-axis parameter. That x-axis parameter is here t, so that's why I wrote t, and outside I wrote f. That f explains the name of the function. So we can write sometimes like this, f of x. So what is the meaning of this one? F is a function name, so f function is changing with respect to the x value, right? Similarly I am writing now g of x. G function is changing with respect to the x, and similarly I am writing f of y. So f function is changing with respect to y, right? So from all, this is the standard representation of the signal, and now onwards always we have to write within the bracket t, because here we have to take the function is changing with respect to the time, and the function name we can write any name based on the application. If it is a voltage, we can write v of t voltage, v of t voltage changing with respect to the time. If it is a current, we can write I of t, current is changing with respect to the time, and we can write power also, p of t, power is changing with respect to time, right? So v, I, p, these are explains the name of the functions, and within the bracket I wrote one alphabet. That alphabet always explains the x-axis parameter. So now onwards please try to use this analysis. And now I am writing here the complete block diagram of the signals and system. So in this block diagram, just we have to take only one block here. This block I am assuming as a system. Okay, what is system? I will explain later the definition of the system. Okay, so whenever one input signal is connected to the system, the external signal is connected to the system to process purpose. So that external signal is called, generally we can call it as an input signal, or we can write it as an excitation. Then the system performs some operations, like it processes the signal and later which gives the output. So finally the output of the system is also comes under a signal. For any system, input is a signal and output is also a signal. Both are signals only, right? So here in this subject, to represent the input, always we have to use this type of representation, x of t. X of t. X function is changing with respect to the time. Generally this x name is generally used for the system input, and system output purpose we have to write always y. Y always explains the output of the system, and whatever the system operation explained by system function, the system function representation purpose we have to use h variable. H alphabet. So now onwards, just try to remember wherever the x of t is there, that x of t is we have to take it as the input of the system, and y of t is defined, that is always acts as the output of the system, and h of t is acts as a system function. So this complete part is generally comes under introduction to the signal.